name is Jonathan Ward. I'm from Ward Technology Talent. We're an IT staffing firm, but we've started up and run the Mobile Learning Lab for almost 4 years now. We've got 2,000 members in the meetup group. I'm sure that's how a lot of you are here, some of you obviously through Infusion. So a couple quick things. There's a bunch of my teammates that have these shirts on as well, and really appreciate all their help and support. If you guys have any suggestions for future topics for Mobile Learning Labs, please reach out to any of us and let us know. We've got a format tonight that's pretty cool. We have 2 speakers. I believe we have a demo. Sometimes we do panels. Sometimes we have 1 speaker. So if there's a format that you guys like, or if there's subjects you want us to speak about, please let us know. The whole, objective of the Mobile Learning Lab is to give back to the community, and you're the community, so please let us know what you want to hear and what you want to learn about. So thank you all for coming. Thanks again for Infusion for hosting, and I'll hand it over to Jeremy to get things started. Thanks, Jeremy.
All right, thank you. And by the way, there's tons of room up here if anyone wants to sit, who's standing back there. So anyways, what we're here today is to talk a little bit about cognitive services and how artificial intelligence is transforming the way that we can do mobile applications. But to start out with, I'll give you a little bit of a detail about who I am, what sort of work I do. So I am an architect here at Infusion. My focus historically has been on doing digital installations. So that includes both traditional kiosk and signage, as well as some of our mobile kiosks, which we've been doing lately. We are a big Samsung partner, as well as a Microsoft partner. So we've done work with firms like BAE Systems doing in-flight entertainment and whatnot. My next kind of area of focus is innovating around how we can use immersive technology, and specifically I'm doing some work with the HoloLens and virtual reality, but also how we can use some of these new cloud services to enhance the experience within these applications. So a pretty wide swath of technology, which I'm covering, but I have a lot of experience with both some of the vision processing as well as the bot framework stuff. So I've been playing with cognitive services for a while, done a number of demos and pre-sales activities, so have some sort of knowledge about it. Anyways, I wanted to start out with artificial intelligence. Artificial intelligence is something that we've been talking about for 50 years or so. But we're starting to see fruits from that effort, and to the point where firms like Deloitte, all the big industry experts right now say that this is really the trend. This is how we create applications and services which are intelligent and are personalized to us. So the technical definition of artificial intelligence is theory and development of systems which are able to perform tasks which would normally require human intelligence. These include visual perception, speech recognition, decision making, and language translation. So a wide swath of sort of areas. I'm going to get into some of those in more detail. But you can see here, this is actually this year's Gartner sort of thing. This are the areas of growth that they see, and it's all around applied AI, intelligent applications, intelligent things, feeding into some of the downstream systems. So this is a very applicable topic, I think, and it really power our next generation of applications. But to get into artificial intelligence a bit, we need to understand how, to emulate human intelligence, we need to understand how human intelligence works. To start with that, I wanted to talk a little bit about neural networks. So neural networks are really amazing, and they're the way which we're able to form the associations which define us as people. So the design of these networks is really based upon how our brains are structured. So within your brains and throughout your body, thought is done by neurons. So neurons are these central hubs. And they have 2 parts which are really important. So they have axons, which are these connection points, and they have synapses. So all the neural networks and the way that our brains work is these axons connect to one or many different neurons to form these meshes. And while it looks simple in this kind of diagram up here, you realize that even for the most simplistic things which we can look at with microscopes, they form very complex systems. And as you age and as you learn things, different connections are formed between these neurons. So it's a very dynamic system, and it's something which encourages and allows for learning within our brains. So great way it works in our brains. So we as computer scientists want to understand how can we model this within computers. So the basic premise of neural networks and machine learning hasn't changed an awful lot in the last 50 years. Neural networks always start with a series of inputs, and this might be input from vision and camera inputs. It might be input from text. They go through these processing layers, which act very much in the same way that our neurons work. So one processing node might be able to inform another, and by going through these processing layers, and there can be many, many, many layers of these, we are able to assign weights to these kind of links to come out with a series of outputs. So the way that it works is that we are able to take sample data sets, move them through this neural network in order to produce outcomes which we can then validate, which can then inform what these weights and how important each of these processing layers are. Anyways, I realize this is pretty dense, and dense for some. For data scientists, this is like the most basic thing ever. So, but I just wanted to kind of establish what we're talking about, and why it's kind of so powerful. But what's important to know is that while this concept has been around for a very long time, and in fact in the 50s, Turing proposed these sort of learning machines. The process and progress around these has accelerated tremendously. So I'm sure we all remember in 1997 when Deep Blue beat Kasparov. That was only a branching factor of 35. So just a little bit of an illustration of what that means. It means that in chess, you generally have about 35 moves you can accomplish, you can do at any certain point in the game. You fast forward a few years until 2015, Google's AlphaGo was able to beat a player in the game of Go, which means that for each time you have 250 different combinations. So within the short period here, 13 years, or math, we've been able to go exponentially, perform exponentially more processing. And this trend is continuing. With cloud computing, with the availability of these massive computing resources, we're not constricted to these data center sort of installations that we had for either Deep Blue or Watson. So specifically, it just allows us, and as you see through my presentation, particularly as we bring these two software as a service, they're much more kind of accessible. But I want to talk about kind of what the common applications are right now of AI, and they're actually pretty widespread. So from things like autonomous vehicles, there's a ton of press at CES and other kind of venues around the future of self-driving cars, and that's an accelerating process. Within 5 years, practically every manufacturer will have some form of autonomous vehicle in their fleet. We actually deal a lot with finance, and we're starting to see a lot of work within fraud detection, within financial modeling, to uncover these sort of relationships which would be impossible to derive by just sheer analysis of it. Of course, we have search engines. The ability of Google and Bing and these sort of search engines to be able to classify assets it finds on the internet, not necessarily through just straight tagging in the past, but through analyzing the content of those pieces of thing, and to be able to recognize inappropriate materials and these sort of things, which would be impossible without a learning network. To chatbots, maybe not Tay, but we see Siri, and we see Cortana, and we see really a proliferation of these sort of chatbots which are hitting the market and are really shaping the way that we interact with businesses. And then the complementing set, which I characterize as a little bit more applicable for mobile, is again hey, you have chatbots on one side which are kind of for corporations. On the other side, you have personal assistants. So again, these might be your Cortana and Siri, which perform not only operations like text-to-speech and speech-to-text, but also can understand conversations you have with them. They're able to understand the context of its integrations to calendars and other sort of parts of its environment. It hooks into your applications. We're starting to see a lot of work in personalized recommendation engines. We've all been on Amazon and realized that it's able to recognize that since you bought this, you might want these complementing set of products. In the past, this is something which was hard-coded in, and people will spend a lot of time trying to make these associations, but they weren't based on data. They're based upon someone's perception of this goes with this. We're starting to see that Amazon's a great example. 35% of their sales come through products which they recommend to customers on a personal basis. And that's a real amount of money which is being generated through this AI work that they're doing. Image and video processing, again, we've been talking about OCR and things like that, for 20 years. But we're starting to see this really come to manifestation. If you used any of the kind of translator applications, which kind of blend these two together, you know that you can go and go to a foreign country, be able to scan a menu with your phone, and be able to translate it to your native language. That's something which relies upon the AI for the OCR. It relies upon AI for the translation, and we're starting to see a lot of applications which use these capabilities, which would be very difficult, if not impossible, without a ton of work in the past. And just to say why it was a ton of work, the problem is that neural networks are complex. Even when I presented the most simple kind of manifestation of it, it's hard to kind of take in exactly what's happening. And they're very dynamic too. So as you train a neural network, its behavior changes, and it's very hard to prove the correctness of these neural networks. So generally, who creates these neural networks? Generally, it's data scientists. Generally, it's people who have a large background in advanced mathematics. They require huge training sets to be able to recognize OCR of every possible piece of text and every possible lighting combination. You need a ton of data to be able to do that. You need huge computing resources. Unless you have your own cluster of servers which are doing your neural networks, or maybe a GPU cluster and whatnot, the speed that you can do so really constrains you. And correctness is an important one too. Particularly in our field where we do a lot of work with finance. Being able to prove an algorithm is correct is very difficult. So if you were to do these algorithms by yourself, having that correctness and knowing that you're deriving the correct result is very difficult, and it generally requires a mathematical proof, something which is something which is not to be taken lightly. So those are some of the problems with doing your own AI. I'm just going to go through what kind of the solution is, where the market's landing on in terms of making these services and advanced capabilities available to everyone. So a lot of companies, Microsoft in specific, really recognize the fact that these capabilities are a universal tool. They really, within the next 2-3 years, are going to be incorporated into, I would say, most applications, most major applications that were coming onto the market. And to accomplish that, these algorithms really need to be exposed not as you writing something and running it in your own data center, but be exposed as a software as a service. And what we see is that every public cloud out there is exposing these services because they're perfectly tailored to these services. So, Amazon has theirs, obviously Azure has theirs, IBM has theirs. They are all based on the fact that, there are huge cloud resources now which are able to run these very advanced, applications and expose them as SaaS offerings. So by doing this, what it really allows you to do is to move into this, fourth revolution, fourth industrial revolution, as many are calling it, where we are able to, combine the physical aspects of our hardware with intelligence, to be able to make it our own and make computing our own, to be able to, really propel our, accomplishments. So that's an entire topic in itself. But what I want to talk about is one specific implementation and one that we've had a lot of experience here in Infusion. So what that is the Microsoft Cognitive Service Suite. So Microsoft Cognitive Service Suite previously was known as Project Oxford. It was something which was born of Microsoft's research and development arm. They've been working with it for the better part of 5 or 6 years. And what it is a set of at least 25, and they get added on a pretty regular basis. So machine learning API sets, which cover a pretty wide range of capabilities, which we generally associate with AI. So, and I have slides for these, but these are broadly characterized as computer vision, speech recognition and processing, language, knowledge, and academic knowledge, as well as advanced search. So the first one that we like to talk about, and I actually have a quick demo of later, is computer vision. So doing things like computer vision includes things like being able to look at images and analyze them for content, analyze them for faces, analyze them for all sorts of categorization. And I actually have an output here from one of these image APIs. And you can see here that simply based upon this picture, it's able to, and I know it's hard to read, it's able to recognize that this is a picture in water, this is a sport, this is someone swimming, this is a person in a pool, and it's able to tell this with a certain level of confidence around each particular sort of tag. So this in itself is a pretty powerful sort of methodology, which you would not be able to accomplish by yourself without a huge set of data such as Bing and these other services have. So again, face recognition is obviously something which they can do. You can see here that it's able to recognize that he's someone who looks like he's 28 and male. Also able to detect things like emotions. Is this person happy? Are they neutral, angry? To be able to get that sort of sentiment analysis. Content moderation is something which is pretty popular too. So be able to recognize things like adult content which should be blocked and whatnot. And then, they also have a pretty wide other suite of things like, stabilization and whatnot, which actually come from their Azure Media Services, but are now part of the Cognitive Suite. So that's one set. The next one is around speech. So speech is really, a few things. Speech to text is one thing, and these services all came from their Skype offerings and some of their translation offerings. So, not only can you recognize the speech turned to text, you can also get additional insights from their translation engine as to what the intent is, what the grammar is, and based upon the output, based upon what you want to say to the person, you can turn that back into speech, which is very kind of natural, and you can do a lot more sort of advanced stuff around there. Language is obviously something which is dovetails into there. So we have things like spell check. You have things like the Language Understanding Intelligence Service, which is actually their shorthand for their bot framework. But we also have awesome stuff like analytics around sentiment and be able to recognize languages. You have translations. You have the ability to break apart words. These are all things which are very hard problems to solve, but now you can get them via SaaS offerings. And the last one is their knowledge base. So this includes things like recommendation engines, which you can get purely out of the box, and not only sort of personalized ones. You can get item to item, and you have a pretty wide range of what you can do through here. You're able to get at entire sets of knowledge from academic sources, be able to link from your particular text to these academic sources and provide additional context to your application. So again, a huge set of APIs, and this is just a kind of a characterization of them. There's actually a ton more which are a little bit more obscure and hard to describe. So talk a little bit about pricing. So what is really awesome about these is that they all have a free tier of implementation. So as you create your application, as you create your prototypes, doing these very complex operations is essentially free until you move out and want to get into production. And when you get into production, they've made it really straightforward to integrate that with all of your existing Azure stuff. So it gets added to your same bill, and there's a very sort of straightforward pricing structure to it. But so that's a lot of stuff, and there's obviously a lot of kind of characteristics about it. You might ask, like, why is this pertinent to mobile? Why would we have these in our mobile applications? The reason why is that the mobile form factor is the most personal form of computing, which I think that there is today. And the purpose of these is to tailor the experience to you. AI is the perfect vehicle to that because it is able to understand everything from your contacts to how you interact with the device, and through sensors, through how you use it, it's able to perform those customizations. And again, to provide context to the actions which you're doing. Because contextual computing really is one of the next phases of everything that we're seeing from mobile to some of the immersive stuff which I mentioned before. And again, like, we already know that some AI-based things like Siri, Cortana, Alexa are already a pretty big part of mobile computing. And indeed, Gartner predicts that by the end of next year, these assistants will be able to recognize our voice. They'll be able to recognize our intent through things like facial recognition and sentiment analysis. And then by 2020, there's some predictions that these sort of personal assistants will take up about 40% of the interactions we have with mobile devices. So it's not to say that everything will be like okay, Google, tell me this, but this will be the glue that will tie together the mobile systems of tomorrow. So very quickly, like, how do you get started? So first off, you obviously sign up. You can just Google it, Microsoft Cognitive Services. As I mentioned here, you can get started for free. You don't even need to provide a credit card, I don't believe, to do that. So once you do that, you can pick which services you want. And from there, you can get your API keys. Once you have your API keys, there's 3 different ways that you can access these APIs. So there's a very clean REST API, which works cross-platform, or work in kind of any scenario you want. If you do want to use sort of the native libraries, there are published libraries for both iOS and Android native, as well as some nice Xamarin portable class libraries, which you can use. So a pretty wide range of things. So whatever sort of methodology you use, it should be pretty straightforward. I just want to give one very specific case study that Microsoft likes to talk a lot about, and this is around Uber. So everyone knows Uber. You have drivers who sign up to be these drivers. They've had a problem about how do you ensure that the driver who is using the device is actually the driver who's registered. So when you register, you need to register things like you have insurance and you have the appropriate driver's license and whatnot. So there's always a kind of the worry that someone will sign up with one account, but then will just go and give the device to someone else to actually drive for them. So this is something which Uber decided to take on. So what they did is they want to use things like the Face API. So they used, this is a cognitive service API. So now they're actually rolling this out right now. When you register as an Uber driver, you take 2 or 3 selfies, and that establishes your face in the database. What happens is that every time you launch the application or on a random basis, it will ask you to take a selfie, and then based upon the recognition of that compared with the sample images, it's able to kind of authenticate you, and the driver goes on his way. What is pretty amazing about this is Uber's a big company. They're a pretty complex application cross-platform. The entire thing took 3 weeks from when they started it to when they were able to get this AI algorithm into their application into production, which is incredible. And with no additional server components, entirely based upon the SaaS offering, and based upon the pricing structure, it is almost nothing for them to be able to do an algorithm like this. So I wanted to, if the crowd is kind of up for it, I wanted to have a very quick look at the code of this. Is everyone okay with a couple of lines of code?
Yeah.
Okay. So I am going to be doing something in Xamarin here. I've chosen Xamarin because it has a really nice PCL library. So what I want to do here is, I've actually just started a Xamarin project. Literally, all I've done is say new project, and I've added a couple of NuGet packages. To be specific, they're the Project Oxford one and the one to take pictures with the camera. So nothing fancy. It just takes about a minute and a half to do so, and I didn't want to kind of bore you guys. And let me just get my, unfortunately, I saved my snippets here. 1 second. Sorry, I thought I had that open. Sorry about this. Cognitive services there. Okay, so I have a few things. So Xamarin is all based upon XAML. So the first thing I'm going to do, I'm literally just going to paste in two things into this application, which is again dead stock. The first thing I'm going to do is paste in my UI. So my UI for this is very simple, and I'll make it a little bit bigger for the folks at the back. So very simple UI. Actually, I don't need this label here anymore. What I have is a grid with a couple rows, couple columns. I have a button at the bottom. I have an image and a list view. No, nothing special here. So what I want to do now is to bring in the entirety of my cognitive services stuff. So what I'll do here is I will go into, again, my C# file right here. So this is in a portable class library. So this code will actually work across iOS, Android, and UWP, so both desktop and Windows Phone devices. So did I change the name of that? 1 second. Okay, 1 second here. Not quite as. Maybe I shouldn't have done that. Okay, just 1 second here. Okay, so let me show you what we have here. So what I've done here is, I'm not sure if my build is going to go. Let me build it, and anyways, I might just go through the code and not deploy it. But all that I've done here is taking a picture with a device. So again, this is something which is cross-platform. You can do this for each one. All I'm doing is getting this file stream. And then after this, the entirety of the cognitive services bit is encapsulated in these three libraries. So the first, the three calls. So the first thing that happens here is that I establish this client. So as I mentioned, this is one of the great Xamarin PCL components, which are there. In there, I paste in my my API key, and obviously you do this in a more enterprise way than just through a literal string. But through there, you get this great client, and from there, you're able to issue things like get a description of a particular image. And based upon that, you get a collection of tags, and this is the entire thing. So this is all that's required to get that image-based sort of recognition, which I showed in one of those previous slides. Let's see if this. I may have messed up something here. Okay, fine. I'm not gonna. Yeah, no, it didn't actually do that. Okay, I'm not gonna debug it live here, but rest assured, that is all that's required to get started with these APIs. So anyways, I also want to talk a little bit about sort of the future direction which we see here. So as I mentioned, immersive technologies is one of my kind of key area of focus. And what we're seeing is that obviously AI is all about using this machine learning to be able to develop these deep insights. New devices like HoloLens, like virtual reality, whatnot, have a lot of sensors which aren't really, accessible or, are there in mobile devices. So what we're seeing is these sensor feeds can be used to achieve some, pretty interesting things like with AI. One case study we like to talk about a lot is Lowe's. So what Lowe's has done is they've created an application which is able to take a user's what's the word? It's the board, Pinterest. It is able to take users' Pinterest boards. You just provide them the name of your board. It's able to ingest those those Pinterest boards, but your kitchen vision. And lots of people create these before they do their kitchen renovations. What it's able to do is to analyze these pictures from here, provide information about what sort of stylistic sort of things people want in their kitchens, and then be able to recommend one of 10 different kitchen configurations which that particular customer is interested in. It's then able to go and, obviously with the HoloLens, you can, see a virtual representation of that. But beyond there, they're able to use the gaze and the orientation of the headset to know exactly what you're looking at and be able to understand, hey, you're looking at this sink and, it has an associated sentiment with it. And to know how successful it is, in each of these particular choices that it's made. And what they're able to do with that is the salesperson who's assisting them through this journey can say that, hey, you're looking an awful lot about the sink and maybe you want to consider a different model. And they're able to generate these insights on things which the customer wouldn't be telling them directly anyways. And they're able to get a lot of upsells and a lot more sort of knowledge about what exactly their customers want. And then the other one which I like to share is one which is really interesting. It was shared at the Build conference, where they're using this technology to generate applications for people with visual impairment. So this gentleman here is blind. So through an application which they're able to develop using this device built into these sort of shades here, they're able to see who's in the room, what sort of objects are there. It's able to do OCR and so you can read menus and whatnot. And he might have a very slight, he can see colors, but he certainly can't read anything. So these sort of applications are setting the stage for not only visual impairments but other impairments. So really using the cloud and these capabilities of our devices to augment human senses in a way which is very kind of palpable. So just to kind of cap off my presentation, a few takeaways. So AI, I'm viewing as a very disruptive force within mobile. It will be the differentiator in applications in the next couple of years as I view it. The second part is that the barrier to entry for these technologies is so low right now that literally through my sample, which didn't really work well, literally with a couple lines of code you can access these machine learning algorithms which would take months and years to implement on your own. And we should be using these algorithms and trying to find a way to give our application these superpowers which we see in the next class of world-class applications. So that's about it. I'd be glad to take any questions about this sort of stuff.
I was wondering about the differences between different services, like Watson or what else?
Like Amazon is one too. They all have them. I would say that the core set is pretty similar between the different ones. But with that being said, different clouds are focusing on different things. Like Watson's had a much sort of deeper look into insights and academic knowledge. One of their big focus areas has been helping doctors find kind of obscure case studies and things like that, which they may not have known before, because there are millions of case studies and things like that, particular cures for cancer and whatnot, which work on certain patients. So they spend a lot of effort trying to solve those sort of problems. Microsoft, has spent a lot of time because they own properties like Skype and translators and language understanding. I think their language stuff is pretty first rate, and so is their bot. They've made a pretty substantial investment in bots. I would say that Amazon's recommendation and some of the things which they've used within their own platform are world class. But with that being said, each of them does offer a pretty complete set across the board.
I was just kind of curious, like, I don't know if you've ever used, but for like web speech API, like Google has like that free kind of service that you can use. I think it's like built into HTML now.
Yeah.
That you can just kind of use.
Mm-hmm.
I think it only works on Chrome maybe. But anyways, that compared to like other speech offerings from like a SaaS provider.
Well, I mean, I don't know the specific details about that, but I would be shocked if that was not using some sort of a SaaS offering on the back end. Like, unless you can tell me that it doesn't use any bandwidth.
No, it probably does. It probably definitely does.
Yeah.
But like, I was just kind of curious, like, if you had any experience or like recommendations for wanting to include kind of like voice to do stuff, like to control your web apps with voice through AI.
Yeah. I mean, like, that's certainly an offering. Like, as I'm saying, like each of these clouds does have an offering around that. Like these public, REST APIs offered by cognitive services are tailored towards that. I know that IBM has one, tailored towards that. Obviously the Google one is kind of more deeply integrated to Chrome because they want to, kind of push that sort of whole ecosystem. So what I'd really recommend is looking around, the licensing costs for each of these technologies. Like, it does make a pretty big difference if that's your core thing you're doing within your application. And then after that, I'd recommend going to the demo pages. Like, I know that certainly the cognitive services has fantastic demo pages for all of their services. You can even put in a sample, record something or you can do a lot with the sample pages. And our experience is that each of the cloud providers is trying to provide this pretty rich dashboard sort of experience so that you can try them out. So, while I would say the cognitive services is probably our preferred for most things, just because it's a pretty wide range, it's not to say that we haven't used some other offerings, particularly within the Amazon sphere.
What about like data privacy and things like that? And like, is there a flexible option? Things like that?
So I mean, that's obviously a great sort of concern. With that being said, they're pretty sort of intelligent about it. The insights and the materials used to train these models certainly is based upon sort of public spheres of information. But within, and again, I'll speak within the cognitive suite. If you are going to input information into these systems, they are kept in sandboxed environments for you. So the Face API is a great example of that. So obviously, pictures of everyone's faces associated with their profile is a very personal detail that has to have a level of security associated with it. So if you do that, you are, those results do end up in your own Azure, sort of blob containers and storage containers. And, as I mentioned, it is based on Azure. So you have full flexibility to control those data securities just as you would any other Azure services. So if you have a particular need to ensure that, hey, the data doesn't leave Europe or something like that, you can do so by ensuring that your particular data storage is set up in that way. So again, my knowledge is much more with Azure, but it's my understanding that each of the providers has a similar sort of level of security. But needless to say, there is a lot of effort, and all these companies take it very seriously. Yep.
Yeah. Is there any SDK support, for example, besides the mobile? If I'm not a C# person, if I want to use your service, do you provide any Python or Node.js?
There are probably some kind of open source things. I would recommend just going out they are very clean REST APIs. So as long as those platforms have abilities to use REST APIs, which everyone does, there has to be something. With that being said, like for those particular languages, I would be shocked if there isn't someone who has a GitHub repo somewhere with a whole bunch of.
Azure official SDK?
Oh, like Azure for sure. Like if you're talking about the core set.
For node service, like
Not as far as I know. Generally the guidance is to use the REST APIs. Even some of the sort of Xamarin PCL things are open source too. So the REST APIs really are the official source of truth, but there are kind of packages for different platforms which are supported to different levels.
Back a few slides ago, you mentioned Google, the official name of the Microsoft platform, or whatever this
Project Oxford.
was, yeah. Microsoft Cognitive something?
Microsoft Cognitive Services.
Services, okay.
Is that the question?
That's the question.
Okay. Microsoft Cognitive Services, previously known as Project Oxford.
Cool.
I kind of had a question more so like I've seen a couple presentations on neural nets, but they all kind of just show like circles, lines, more circles.
Right.
And then I'm like really curious about the lines.
Well, the lines are weights. So basically, processing, and it's tough to really quantify because the processing in those internal nodes depends upon what the problem set you're trying to solve is. So in image recognition things, basically that might be something which detects certain colors or detects certain proximity, of one pixel to the other. But those lines basically represent the connections between those processing nodes. So what happens is that it can based upon the training it does, it determines the optimal, sort of path and optimal weight to get to the known result. So if you pass in a picture of a cat to this neural network which does image recognition and tell it, this is a cat, it will find the optimal weights between these processing nodes, and it's and in each one it's kind of it's normally a probabilistic thing. So all the outbound connections should probably add to one, and based upon that, it kind of runs through thousands, millions of things to be able to determine the optimum way to detect a cat.
But that's not something like you as the developer have to write. Like you.
No, and that's. Yeah, and that's exactly why we don't want to write these. Like unless you're a data scientist who understands the intricacies, and that's just one form of neural network. Like there are from what I was kind of reading, there are probably like 20 different types of major neural networks out there. They each have their own sort of way of doing weights. They each have their own ways of traversing one way, then backtracking. They each have their own way of reinforcing learning. There's a lot of complexities around that, and it's a very kind of hard problem. The algorithm that was used for the chess, Deep Blue, is very different from the algorithm that's used in the Go, AlphaGo thing. And the new one is kind of more of a deep learning thing, and there's a lot of complexities around that. Like, I don't claim to understand fully how to implement these things. I've never made my own neural network, but my understanding is that in each of these things you just take a series of weights to be able to know which processing nodes you are kind of interested in. Yep.
So this is all great if you have connectivity.
Hmm?
What happens when you don't have any connectivity?
Well, you don't have connectivity. You're not. You'll be able to build a much weaker AI on your mobile device specifically. Yeah, yes and no. I mean, with some of the, and not specific, okay, I'll back up. Not specifically within cognitive services, but if you were to talk about the wider suite of Azure machine learning, a lot of that is around building your own models in R and some of their derivatives. Those models can then be brought into your on-prem thing. So we are seeing some of those hybrid solutions be used in some of our insurance clients who are trying to do image recognition for collision damages on cars, for instance. They do a lot of that, develop the model and whatnot in their on-site things, but then one offloads some of that capacity off to the cloud. So I would say that if you are going to do a hybrid model, you need to have your own models, which means you need to kind of understand how to build these things.
I think we'll got another speaker coming up. I'm sure you'll be around to answer some questions after, right, Jeremy?
Yeah, absolutely.
Awesome. Let's thank